Okay, this lesson is for Mrs. Cucci's College Now Precalculus class. We are on lesson 4.3, talking about logarithmic functions and their graphs. Okay, so by the end of this lesson, you will be able to find common logarithms and natural logarithms without a calculator, with and without calculator. You'll be able to convert between exponential and log equations. You'll be able to change logarithm basis, graph logarithmic functions, and solve applied problems involving logarithm functions. Okay, so just a reminder, the inverse of an exponential function is a logarithm. So the inverse of an exponential function is a logarithm. And that's a review from Algebra 2 Trig. Okay? All right, so what we're going to do first, we're going to take a look at the graph of x equals 2 to the y. And so how we're going to do that is we're actually going to do this by hand because we know we can't graph x equals in our calculator. So we're going to build a table of values and plot those points. So x equals 2 to the y is what we're dealing with. So we'll build a table. X, y. So what we want to do is we want to kind of think about working backwards because it looks like this y is what's going to be giving us the values. So we're going to work backwards from there. So let's start with y equals 0. Okay. So when y equals 0, we get 2 to the 0, which is equal to 1. So there's our x value. Okay. So that gives us our first point of 1, 0. Next one we're going to try is y equals 1. 2 to the first power is 2. So there's another point. Let's try 2. 2 squared is 4. 3. 2 cubed is 8. Okay, so now we've got some positive values. Let's take a look at some negative as well. Negative 1. 2 to the negative 1, if you remember correctly, what this does is it makes a nice fraction for us. Oh, that's annoying, isn't it? Okay, negative 2, same thing here. 2 to the negative 2 is going to be 1/4. And negative 3 is going to give us 1/8. Okay, so we have some points. Okay, so let's take a minute to graph that. So we're going to build our axes here. Okay. All right, so we've got the point 1, 0, 2, 1, 4, 2, 8, 3, and then going backwards here, we have 1/2 negative 1, 1/4 negative 2, 1/8 negative 3. So as you can see, we're getting closer and closer to that y-axis. And we can go ahead and sketch this in. Now what you notice is this does get closer and closer to this y-axis, but it never actually touches. And what that tells us is this y-axis is an asymptote for the function y equals 2, x equals 2 to the y. Okay. So if you remember, this graph actually does look a lot like the graph of y equals 2 to the x, except it's reflected across the line y equals x. Okay, so this line here, or diagonal. Okay, and the reason being is y equals 2 to the x is the inverse of x equals 2 to the y. So it looks something, let's see if we can get it right here, right? Like this. Okay? All right, so if we want to find the formula for the inverse, or f to the negative 1 of x, it's actually pretty simple. All right? Our first step is to switch the x and y. So it becomes if our original function was y equals 2 to the x, it becomes x equals 2 to the y. And then we go ahead and we solve for y. So y equals the power to which we raise 2 to get x. So this is where we start to get into logs. Okay, so in order to solve this for y, we have to put it into log form. And that's going to be y equals log base 2 of x. Okay, which is this function right here. Okay. All right, so log function base 2. This is read, this function right here is read as the logarithm base 2 of x. And what that means is the power to which we raise 2 to get x. So an example of that is if I have f of x equals 2 to the x, then f inverse of x is log base 2 of x. These are inverses of one another. Okay? If I want to evaluate the inverse at 8, all I need to do is plug that value in, and it's going to give me a value of 3. Okay, so evaluating is very simple. Just like it has been with everything else, we just plug that value of x in to see what we get. All right, so for any exponential function, f of x equals b to the x, its inverse is called a log function, a logarithmic function with a base of b. Keep in mind, we can determine the inverse of a function graphically by reflecting it over the line y equals x, and that will give us its inverse as well. So keep that in mind when we're doing these, is you can always check or you can always graph the inverse by reflecting over that line. So we define y equals log base b of x as that number y such that x equals b to the y, where x has got to be greater than 0 and b is a positive constant other than 1. Okay, so now we're going to look at some compare and contrast, and you're going to put this directly into your notes. So we're going to compare and contrast exponential and log functions. So let's take a look at exponential first. So look at our exponential and our log. So an example of an exponential is y equals a to the x. The log function, well, the inverse, right? X equals a to the y, which we know is f to the negative 1 of x equals log base a of x. Okay. A has to be greater than 1 here. A also has to be greater than 1 here. These functions are continuous, as are these. Okay, which means there's no holes, you don't have to, there's no breaks or jumps. This function is 1-to-1, which means it passes the vertical and the horizontal line test, as is this one. My domain for exponentials is going to be all real numbers, or from negative infinity to positive infinity. My domain for logarithms, however, is going to be all positive numbers. So you're going to have 0 to infinity. Okay. My range for exponential is going to be all positive. So 0 to infinity. And my range for log is going to be all real numbers, negative infinity to infinity. So now notice here that these two are flip-flopped. And that should make sense, because if they're inverses of one another, your domain and your range switch. Okay. Okay, both of these functions are increasing on the interval, negative infinity to infinity. The exponential function has a horizontal asymptote. Which is the x-axis. And the log has a vertical, which is the y-axis. Okay. Y-intercept for my exponential, 0, 1, which is going to be my x-intercept for my log, 1, 0, inverses. Here there is no x-intercept because it's my asymptote. The x-axis is my asymptote for my exponential. And here there is no y. Again, because the y-axis is my asymptote. Alright, so that's a simple compare and contrast. And you should know the majority of that information just by taking a peek at the functions themselves. Okay, so make sure you get this into your notes. You can pause it here to get all this down. Okay, so we're going to find the logarithm log base 10 of 10,000. So the question you have to ask yourself is, what exponent do we raise to 10 to get 10,000? Okay, so 10 to the what power is 10,000. Also, we can simply use our calculator to evaluate log base 10 of 10,000. And you should get 4. Okay. Find the logarithm of log of base 10 of 0.01. So what would I have to raise 10 to get 0.01? And you should be able to do this right in your head. We know that it's going to be a negative value. Okay. And we get negative 2. Log base 5 of 125. So what is the exponent to 5? That would give us 125. And we know that that's 3. 5 cubed is 125. Log base 9 of 3. So what would I have to raise 9 to get 3? So this is getting smaller. So if we think about this, we know 3 is the square root of 9. So what exponent represents a square root? That's 1/2. Log base 6 of 1. So 6 to the what power would equal 1, We know that anything to the 0 power equals 1, so that one should be quick and easy. Log base 8 of 8, 8 to the what power would equal 8? That would be 8 to the first power. Okay. So log base b of 1 equals 0 and log base b of b equals 1. This is for any logarithm with base b. So these are always going to be the same. If you take the base and it's of 1, it's always going to be 0. Because we know anything to the 0 power is always 1. Okay? Alright, so we're going to stop here and we'll pick up in the next video converting between exponential equations and log equations. So please make sure you jot down any questions, and I'm going to be checking your notebooks to make sure that you are getting this stuff done. Okay, we'll see you tomorrow.